We're going to do collisions. Here we go. One is inelastic and one is elastic. Let's read this. Two freight cars, each with a mass of a whole lot. 3 times 10 to the fifth. Lord. Collide and stick together. What kind of collision is this, class? Inelastic. One was initially moving at 2.2, the other was at rest. What's their final speed? Here we go. Inelastic collision. Okay. Draw one of these, draw the other one at rest. There's the one at rest. Okay. So this is moving, and then they stick together. So then draw them stuck together. Since this is a inelastic, what is our equation we're going to use? Good. The mass of 1, mass of 2, initial velocity of 2, equals combining the masses together, and they both have the same final velocity in an inelastic collision. Okay, both of these have the same masses, 3 times 10 to the fifth, 3 times 10 to the fifth. Okay, both of these have, it's 2 times 3 times 10 to the fifth. This one's moving at 2.2. This one's 0. We don't know the final velocity. Okay, if this one is moving at 0, right, 0 meters per second, can we cross this out, put 0? Yes, we can. So we just need the initial velocity of this one. So 3 times 10 to the fifth times 2.2 equals, what's 2 times 3 times 10 to the fifth, y'all? What mass is that if you combine them? No, no, no. 2 times 3 to the fifth is what? That's 30,000, so that's 60,000 kilograms. Find the final velocity. So divide both sides by, yeah, divide both sides by 60,000 kilograms. And your final velocity is what? Okay, so this car was at 0. So we do not need this data point. The question was, so should we take out the mass for the second car? Well, it was 0. The velocity is 0, Greeny, so this becomes 0. So now all we have is the mass and initial velocity of one car right here. You combine the masses. Well, each one is 3 times 10 to the fifth, and that becomes 6 times 10 to the fifth. Yes? 2 times 3 times 10 to the fifth? 30,000 times 2? It is 300,000. So it's 600,000 kilograms then. All right. Well, that makes an even smaller final velocity. What was our smaller final velocity then? I apologize. Ma'am, 1.1 meter per second. Okay, 1.1 meters per second is how fast they're both moving when they're stuck together. Now, if you really think about it, it makes sense. Yeah, it makes sense if you think about it. If one's moving at 2.2 and then they stick together, didn't you just double the mass? What did then did you half the speed? You half the speed. If oh, you can only divide them by 2 if they're of equal mass. Okay. Well, they would have to have exactly equal mass for you to do that. Well, that's different now, Greeny, because one of them was also what? At rest. No, if the other one is moving also, now it becomes different. You can't just divide by 2. I would say so, yes. Okay. Now, that was inelastic. They stuck together. We're going to go to number 20 where it's elastic. Okay. Number 20 where it is elastic. So here we go. Tools. Desktop annotate. Tools. Camera. There's a snapshot. This one. No, this one. Number 20. Okay, green. Oh, come on, man. Give me a break. Okay, no problem. A bullet's moving at 475 meters per second. Draw a bullet. Strikes a 2.5 kilogram bag of flour. Draw a bag of flour. Write the word flour on it. The bullet, right there, okay, goes right through it and then out the other side. Did they stick together? They did not stick together. So this is a what type of collision? Elastic. Even though it went this way, it's still, considered bounced off. So now 0.035 kilograms. You got to be in kilograms, okay? This is 2.5 kilograms. The initial velocity is what? 0. Okay, the initial velocity of this is 475 meters per second. The after velocity of this one is 275 meters per second. All right, well, the bag is going to fly off, isn't it? It's going to move. The bag's going to move also. So we need to find the final velocity of the bag. So that would be a elastic collision. Mass of 1, initial velocity, plus the mass of 2, initial velocity, equals the mass of 1, final velocity, plus the mass of 2, final velocity. Okay? All righty. What you guys are going to do on the YouTubes is you're going to figure out this problem. Okay? Well, you're going to do it in their book. Okay, I'll write the data down. You guys got to figure it out. There's your mass of your bullet. Initial velocity of 475 meters per second. Mass of the bag, 2.5 kilograms. That's 0, so you don't even need to write that. The bag moves. The mass of the bullet stays the same. Okay, guys. Find the velocity, the final velocity of the bag. Okay? Find the final velocity of the bag.